the last few days. And it's humid now too. There we go. All right, so here's how these work. So I've got a function. I've made this easy, this part, so it's a show and tell right now. Remember that when you were little and you had show and tell?
Yes, ma'am.
We should bring that back. And then sleeping on the rug business, nap time.
I agree with that.
It's not worded exactly like this. I've already transcribed from the problem statement. I'm going to flash the problem statement up here in a bit. But it's got pretty much this, and it asks you to set up two questions. It asks you to set up the iterated integral first, and then it asks you to compute the area, to compute the volume of the solid that's formed by it, or compute the iterated integral. So step one, what do you think step one is? Draw the region, or else. It's easy. This would be a nice time to have a graphing calculator in case it's some weird hyperbola or something, but looks kind of like this. Here's y equals 4. This is 2. This is -2. Super easy to draw. My guess is on any assessment, whatever you have will be easy to draw, because otherwise it'll be hard to grade. So in your WebAssign, they've drawn it for you. It's unlikely that we'll draw it for you. I just can't see. I know Dr. Gross pretty well. I can't see her doing that. Step 2. Make choices. Make good choices for order of integration. So this decision has to come up front on one of these rectangular coordinate ones. The other one, I don't think it's as bad. So for here, I could either choose to go vertically and go through, and then everything would be y is equal to something, or I could go horizontally. If I go horizontally, I got to solve these things for x, and then I'm going to have plus and minus the square root of something. Like, it's going to be a mess. So my choice is to go with my first inner integral is starting at y equals 0 and starting at y equals the parabola and ending at y equals 4. That makes sense to me, right? And so, again, when I've been tested on stuff like this, I actually remember they would change the order of integration so it's a bear in the direction that I feel like going in. So you can't always just do the y. They can make something ugly where you have to go horizontally and it's better. So beware of that. Maybe I'll give you a sample problem like that so you can see it.
This is kind of reminding me of when I went into the washer and this.
It's very similar, and it's also similar to the area between two curves. So somebody noted that. So you're shooting this way. Vertically, you're going out, starting in at x squared and exiting it out y equals 4. So if I make this decision that it has to go through x squared y equals 4, that means I'm plugging in for x. I'm plugging in for y, because at the fundamental theorem of calculus, the y comes first. So this dy has to match. These two have to match, and dx is next. Order matters. And then the other one's easy. What's the other one limit from what we did the other day? Yeah, the other one's the easy one.
Can you say NY?
So I do agree, like, if I shoot a vertical arrow, it goes through the y equals x squared first and exit, and that's the easiest way to go. So then my iteration, my interval is going to go from y equals x squared to y equals 4. So the thing I'm plugging in is for y. So I'm integrating with respect to y first. Right? Make sense? Like a convoluted way to get everything straightened out.
Because like if you tried to shoot an arrow like from the left, you would have like a function on both sides.
You would have x is equal to the square root of y, negative square root of y. You can do that. It'll work. In the old days, thank God they got rid of that. They make you do it both ways on a test. One way's bad. And that, I guess there's a point there, right? One way's bad. And you then go, oh, I should have done it this way. That aha moment didn't come for most people who were just like checking the box. Okay, now we just integrate this thing. So I didn't do it this way before because I just wanted you to see inner integral, outer integral. This is all about bookkeeping. It's not about thinking. The thinking part's already over. So if you want to, though, I'm going to skip some of the steps. This is how you do it. You integrate the first one, which is 4y squared over 2 from y equals x squared to y equals 4. And don't lose anything. This is your dx. You haven't done the dx. Common thing I used to see all the time. People integrate with respect to y. They feel like they're done, and they leave that circle off that answer, and they walk off. And they've missed all the points of like how to get to the x part. So it is about bookkeeping. And then, so just with parentheses, keep track of everything so you don't lose anything. So I get 2 times y before 16 minus x squared dx. So far, so good? You're too tired and you're just like, sure, just keep going.
Why isn't that like x to the 4?
Because I'm integrating with respect to y.
So you plug in x squared under the y.
Oh, did I? Yeah, you're right. Yeah, the 2 I kept out to the front. 2 is out to the front. I just factored it out. It's right here. So yeah. I just do that so I don't have the constant floating around. That's all. I just pull it out. So then one more. Double the fun. Don't worry. I did all the arithmetic ahead of time. And this is fundamental theorem. That's 2 to the 5th minus 16 times negative 2 minus negative 2 to the 5th over 5. And instead of asking all of you what this is equal to, I will tell you the end result is 5. But 512 over 5 when you crunch all the numbers. Just to show you, like, no eraser burrows on this thing until I get to the numbers. That's enough of the arithmetic. So if you're not sure, actually the opposite group is going to take the advice. If you're not sure of your integration skills and you were sloppy with your integration before and you lost your dx's, do the inner This is the inner work. This is the outer work. Just do it if you want to rack up your points. You're not going to listen to me because you had those bad habits before and you're carrying them forward. Prove me wrong. If you are somebody who is bookkeeping and you don't want to keep like writing and writing, this is the way to do it. Make sure you have your parentheses up, that it's very clear what you're doing each step of the way. Logan, where are you lost? Good? Not lost? Okay, I'm going to give you guys one to do.